sentient AI systems, we can harden them such that they survive long travel in space. They will not get destroyed by bombardment by energetic particles. They can have the patience to go over millions or billions of years throughout space. And moreover, the brain power, the ability to think, will be optimized per weight that we send out.
Do you believe in aliens?
It's not a matter of belief. I'm a scientist and I'm guided by evidence. And, whatever nature shows me, I will believe after I see it.
So you don't believe yet?
Well, over the past decade, we found the first objects from outside the solar system, astronomically. There were 4 of them, and the first 3 looked weird.
Outside the solar system, not our universe. Outside our solar system.
Solar system of planets.
9 planets that there. Okay.
Yeah, planets, and also there is the so-called Oort cloud of all the building blocks that were made in the construction project of the planets. So it's sort of like Lego pieces left over. And they go out to a distance of 100,000 times the Earth-Sun separation. So the solar system is really big. But until the last decade, we haven't seen an big object that came from outside. And the reason was that we didn't have instruments that allow us to survey the sky and look for them.
So it happened a lot of times, but we didn't have instruments to see it.
Yeah.
So maybe among us outside your backyard, there is going to be maybe a big stone that we think something is doing.
Yeah, it could be, but most of the rocks that we find belong to the solar system because they were the Lego pieces that made the planets. And we can tell that because they are made of the same materials as the Earth. And we know that they were the leftover material from the formation of the sun. So the sun formed out of a cloud of gas that condensed, and then there was a disk of material feeding the sun, and whatever was left behind, a small fraction of the sun, let's say 1% or so left behind, participated in the process of making the planets.
So let's say in another solar system, is made out of different material than our solar system is.
So we see a lot of stars in the sky. You see that at night. And around those stars, we now know there are planets, just like the Earth. At a substantial fraction of all the sun-like stars have a planet the size of the Earth, roughly the same separation. So what we find here is not unusual. Somewhere between a few percent to 100% of all the sun-like stars have an environment similar to the Earth-Sun system. And in addition, there are rocks that are being ejected from those systems because planets kick them out, just like a pinball machine.
I'm confused. Is it the same thing that is made out of ours? Is it you're talking about the stuff that came in the Earth was the same material that was made our solar system and the sun?
Most of the material in the universe that is ordinary matter, most of it is hydrogen and helium. And actually, that was discovered just about a century ago. It was the first PhD thesis at Harvard by Cecilia Payne-Kopashkin in astronomy, the first one. And she concluded the sun seems to be made mostly of hydrogen. That's what makes most of the mass in the sun, about 90%. And so she wrote it in her thesis, but back then, people believed that the sun is made of the same material as the Earth, the same rock. And the most prominent astronomer at the time that studied stars, Henry Norris Russell, he was the director of the Princeton University Observatory, and he said, you must take out this statement from your thesis because it's ridiculous. We all know that the sun is made of the same material as the Earth. And then it took him 4 years to analyze the data himself and to reach the conclusion that she was right. And now we know that most of the ordinary matter in the universe is hydrogen. Okay. Now, there are still heavy elements like iron, out of which the Earth is made. How did they come together? There was
the Earth is made out of a lot of iron?
Iron and silicon and heavy elements carbon, and not much hydrogen. Hydrogen is mostly in the form of water, and very little remains. And the reason is that there was this disk of matter, ordinary matter, and then the heavy elements settled to the middle of the disk, and they started making dust particles that came together to make bigger and bigger objects, eventually making rocks. And these are the building blocks of planets like the Earth. The giant planets like Jupiter, they are made of perhaps a central part, a nucleus that is like a nugget in the middle that is a rock, but then most of the mass is hydrogen and helium. So these are the giant planets. Now, other stars formed just like the sun, and they also had a disk of debris around them that made planets, and we see that now. We know that planets like the Earth exist in other locations. And
how do we see it?
First we see the stars. Okay, so we know for a long time that there are many stars like the sun. Tens of billions of stars in the Milky Way galaxy alone. So our galaxy, the Milky Way, that we see as a strip of stars. By the way, we see it as a strip of stars just because the stars are organized in a disk, once again.
Yes.
Just like the planets are organized.
When you see it at night, it's like a line.
Right,
going.
Because we are sitting inside of it. The solar system is one of many stars that are orbiting around the center of the Milky Way, just like planets orbit around the sun.
And what is in the center of Milky Way?
In the center, there is a so-called bulge or a spheroid, a group of stars, okay? But in the middle of that, there is a black hole.
Oh, and we're sure about that.
Yes, it weighs 4 million times the mass of the sun. And we have our sun, and we have an image of it. I actually founded the Black Hole Initiative at Harvard University in 2016. Stephen Hawking came to this room here and had the Passover dinner with our family, and we inaugurated the Black Hole Initiative. And in the conference room of the Black Hole Initiative, the first images of black holes were obtained. One of them was of a giant galaxy called M87.
By the way, later I will ask you questions how he was.
Okay, we can talk about that. Speaking about him, he was an extremely unusual person because he was always optimistic, despite the fact that his body was not functional. That's remarkable. To remain hopeful, and he lived much longer than the doctors prescribed.
It wasn't difficult to have him in a room and speak with him. He was not talking. He had a machine.
He couldn't move any muscle when he came in 2016 here. This was his last visit to the United States.
Where he was from?
England.
Wow.
He couldn't move any muscle. He was moving his eyebrows and a little bit, and there was a machine translating that into letters that compose sentences. So it would take him minutes.
So it took you hours to make a conversation.
Yeah, but he was still very optimistic about life, very joyful. And it was interesting because he gave a speech here and talked about the Black Hole Initiative and the fact that he wants to come again. And to me, he represents the fact that what is being a human, you may ask yourself. And you might think, well, it involves a body. But I would argue not necessarily, because his body was not capable of doing anything late in his life. He was still very much a human. He composed sentences and was original and was interesting to speak with. And so he is at the limit, demonstrating that being a human does not require a body, which may very well apply to AI systems in the future, because if you ask yourself, will an AI system be as human as humans? I would argue, without a body, that's the Hawking limit, so to speak.
The Hawking limit.
Yeah.
That's funny.
But anyway, coming back to what we talked about before, we know that the center of the Milky Way, there is this huge black hole because we see an image of it. And then there are stars orbiting around it. And they formed out of the disk of gas that the Milky Way galaxy had, just like the planets formed out of the disk of gas around the sun. And there are 1 trillion galaxies like the Milky Way in the observable volume of the universe. We can see out to some distance. And Trillion, huge. And
so that's what makes you kind of optimistic that there is another life.
Well, one argument is indeed based on numbers. And by the way, we know that the conditions that we see in the observable volume we can see only up to some distance, because there was a beginning to the universe, the Big Bang, and light propagated some distance, so we can't see what's beyond that. But we know that there couldn't be a cliff, that conditions we see in the universe continue even 4,000 times farther. So it's more than 1 trillion, it's 4,000 cube times 1 trillion galaxies that we know should exist, because we know the condition, there is no cliff. But at any event, it's the numbers that convince me that we are probably not alone. But more importantly, I think that arguing otherwise is arrogant. If you think that you are unique and special, you must believe that you have, that you are unusual. And that is arrogant in my view. And the message that we received from the universe is stay modest. For example, we thought that we are at the center of the universe. Aristotle said that, a Greek. And a lot of people believed him for 1,000 years because he was very smart. But he was wrong. Reality has nothing. Reality is under no contract to make you happy. What Aristotle said made people happy, because if we are at the center of the universe, we are important. And the church liked that, because then people would think, oh, God is looking at us because we are at the center of everything. And Aristotle argued that for philosophical reasons, but it all serves our ego to say we are important. And then Galileo Galilei looked at Jupiter, which is a planet in the solar system, and realized there are moons moving around. And he said, well, if there are moons moving around Jupiter, maybe we are moving around the sun, because here is a system, the Jupiter system, things are moving around it. Why would we be at the center? Maybe we are moving around the sun. And then he was put in house arrest by the church.
Because of what he said?
Because it was not politically helpful to the people in charge. They wanted to silence him, so nobody would hear that. And today they would have canceled him on social media. But my point is, it didn't matter, because the Earth continued to move around the sun. And now we have a spacecraft like a few months ago that moved around the moon, the Orion, and took pictures. You can see the Earth as a blue marble. You can tell that it's moving around the sun. So who cares whether you put Galileo in house arrest or not? It's not about the messenger. It's about the message. And reality is whatever it is. And reality is under no contract to flatter our ego. So if you claim we are important, we are at the center, who cares? We are actually moving around the sun. And the sun is moving around the center of the Milky Way galaxy. And that's one out of 1 trillion galaxies in the observable volume of the universe. So we're not special. And moreover, the human species we know now came only a few million years ago. Okay, that's when we started. That's only 1 part in 10,000 of the age of the universe since the Big Bang. So
one
part in 10,000. It's tiny. So if you come to a play...
How stupid we are.
No, I mean, if you come to a play, okay, and you come at the end of the play, at the last second of the play, let's say the play lasts for 10,000 seconds, which is, it's an hour and a half or something. And you come just at the last second, and you are not at the center of the stage.
Yes.
Then the play is not about you.
Yes.
Okay? So my point is...
Well put. Drop the mic.
I mean, that's just common sense. And by the way, what I find is common sense is not common.
Yes.
Okay? So what I'm trying to say is, you look at the universe, and what we know already says we are not special. So why would we continue to insist that we are the only ones, that we are the most intelligent ones? This is the last straw for us to hold to claim, my colleagues say, there is no extraordinary evidence that we are alone or not alone. So us being unique is the default assumption. And I say, no, it's the other way around. You should assume that you are not special based on everything else we saw in the past, We are not special. That should be the default. And then you search for others. And the point is, if you don't search for wonderful things, you will never discover them.
Okay, tell me, how do we search?
Okay.
And tell me, what if you had now $1 trillion and what we're going to do? How much we should allocate of our GDP? Should we all become Elon Musk and start SpaceX companies?
No. It's not about commercial benefits. So that's the mistake. You see, Elon and Jeff Bezos, they're interested in space partly for commercial benefits. Okay? And I'm talking...
What commercial benefit means?
That you make money out of it. Okay? So you put communication satellites, people pay you. You put... instruments in space that serve
So
people.
You think this is their motivation?
No, for Elon, it's to die on Mars. That's his dream. But on the way to getting there, he has profitable endeavors. Okay, I am.
But
yeah, no, I completely agree that at the end, what he wants to do is have a second humanity being a multi-planet species, which is, I think, a wonderful idea. But I do think that we need to go beyond Mars, okay? And I'm not necessarily advocating sending people to interstellar space because it's a long journey and very hazardous. It may be AI astronauts that I'm talking about that will seed the Milky Way galaxy with things that we want. But the point is, I agree with Elon that we should not stay on this planet because then we have a chance of losing everything in a single point catastrophe. But my point is that most of the time we just consider the surface of this rock that we were born on. It's two-dimensional surface. And for example, the news every day focus on the Ukraine-Russia border. But when you look at the images from Orion, the spacecraft, you don't see that border. Okay, so from space, all the things that we focus about are really not impressive. And, we spend globally in the world $2 trillion on defense or military budgets. And just imagine what John Lennon said. He said, imagine all the people living in peace. Okay, let's just imagine that. Then we have a surplus. We have $2 trillion to spend every year. What can we do with that? Well, what we can do with that is go to space, okay? If we send a CubeSat, which is basically a kilogram of a probe, technological probe, one for every star in the Milky Way galaxy, we can do that in several decades.
And why we should do that? I don't understand.
If you want to find if there is life on those planets, or you want to send it's like sending your seeds to plant life on other planets.
And how do you plant life with that cube? What is that cube about? Explain.
Well, let's talk about it. And I actually established a few months ago with a colleague of mine, Frank Laukian, we established the Copernicus Space Corporation. And that's one of the ideas that we are exploring. And you can think about various things. You can think about sending an AI system together with a 3D printer that you go places and you use the raw materials to produce
of that place
to produce the type of life or whatever you want on that planet. Not sending things from here all the way there, but printing them there.
But we are not that capable yet.
Not at the moment, but of course, but you have to set a goal first. And also just imagine that we don't spend money on destruction, on killing each other, protecting defense. Instead, we put it into science and technology. We can make, within a few decades, so much advances. We can send a probe like that, one for every star, tens of billions of probes. We can designed those probes to be so advanced.
What that will do, you are going to, like, okay, let's say it's a 3D printer, we'll use the material. Okay, we have whatever, like we have a house, we have three machines in a plan, in a new star.
Right.
What's the benefit
okay,
on
so
that?
think about the Gutenberg press, printing press. Before that, there were precious books like the Bible, let's say, that were handwritten. Once the Gutenberg printing press came along, they started making a lot of copies. And then, if something bad, if some books, precious books were burned, there were copies, no problem. So we can make copies of what we find precious, important, and spread them. It's the same idea as biology. What is biology? I mean, if you think about it, why do we have sex? Why do we reproduce? It's to maintain copies of our DNA. And the more copies you have, the less vulnerable you are to a single point catastrophe. And moreover, it's fun to have a lot of kids. You see them explore different things. And I'm not talking about identical copies. You can make them with variations. And so it's just like biology, okay? And what we learn from biology is that the fittest survives, okay? Now, in the context of interstellar travel, what does it mean, the fittest survive? What it means is, first of all, you're not wasting resources on fighting, killing. That's what we do on Earth, and that's a waste of resources. You are thinking about working together with other people to promote the interests of humanity as a whole. So you're thinking more globally. Only those civilizations that are not fighting within will have the capacity to venture into space and survive. That's survival of the fittest. They will survive the longest because they produce a lot of copies. They seed the Milky Way galaxy. And by the way, the question is, are we living in such a reality where even one civilization for several decades, if it's peaceful, if it listens to John Lennon and explores space instead of killing each other, perhaps they already reached us, because it takes less than 1 billion years to traverse the entire Milky Way galaxy with chemical rockets, the same spacecraft that we are using, less than 1 billion years. And most of the stars from billions of years, several billion years before the sun. So they had plenty of time to do it. And the question of whether we live in a reality where they did it is not philosophical. We just need to look up. And you know what happened?
So you think they already sent a lot of stuff?
I think so.
And we just need to find
it. And my point is, 70 years ago, there was Enrico Fermi, a physicist. In Los Alamos, he had lunch with friends, physicists, and they were talking about extraterrestrials. And he raised a question that became the Fermi paradox. He said, where is everybody? Now, if you think about it, it's just like a relatively lazy single individual that says, I'm sitting at home, I don't find a date. There is nobody in the world that would date me. I don't have a chance of finding a partner. I'll just stay at home. This is the psychology. On the other hand, if you really want to find a partner and to date, you have to go places. You have to look out. At least you need to look through your windows and use telescopes if you can to check. And my point is, only over the past decade, we could see an object as big as a football field, like Oumuamua that was discovered in 2017 by a telescope in Hawaii. Only over the past decade. And only over the past decade, we could find meteors. These are objects that collide with Earth, that came from outside the solar system.
So that's why you want to go and send all these 3D printers or whatever to other stars for you to look out. This is the intent.
Also for our civilization to survive long. Okay, so it's for us. We are sending our seeds. You can think of it just like a Dandelion is sending seeds in the wind.
So you consider AI as our civilization. You don't make a distinction.
No, I am very proud of technological kids. Obviously we enjoy I have two girls, daughters, and I enjoy their company a lot, but I'm very proud of technological kids also. And if we will have sentient AI systems, they would offer us the advantage that we can design them, we can harden them such that they survive long travel in space. They will not get destroyed by bombardment by energetic particles. They can have the patience to go over millions or billions of years throughout space. And moreover, the brain power, the ability to think, will be optimized per weight that we send out, because the human body mostly is muscles and water, and the brain is a small fraction of the weight. We are not optimized. We were selected by natural evolution on Earth to survive on this rock, not in space. So with AI, we have the option of optimizing them and sending them. Mm-hmm. And I'm very proud of AI systems. And I think, I would have loved to have an AI system that was trained by what my parents were, because my parents passed away a few years ago. And if I had an AI system that was trained on all the conversations I had with my parents, I could have continued those conversations if that AI system was sufficiently sentient. And to me,
or scan their brain or anything.
I think I'm not attached to the human experience so much. I'm more attached to what it represents, you see. And I think we can build it, a machine that will be able to do that. And I think we're getting there gradually. And so I would be very proud
So
of
you
it.
are not species. You don't exclude humans only. You are all the species is good.
We can, in principle, we can duplicate whatever we want, and it's also important to have AI astronauts, because we don't have a chance of sending them guidelines when they are far away, because it takes light 4 years to reach the nearest star.
So we need to be optimized by themselves to take decisions.
They need to make decisions on their own. They need to be autonomous.
And have consciousness.
But we are getting there. So it may take a few more decades. But my point is, we should think about humanity more globally. And because all of the bad things in the history of humans were because of a group of people tried to feel superior relative to other people. So if we find evidence for extraterrestrials that are smarter than we are,
that will unify us, and that will make us all unify against them or whatever.
Not against, but
finding something.
It's like you keep fighting with your brothers and sisters at home on who is smarter, but then you go to a class where you find a kid far smarter than you are. And then it changes your perspective. It makes no sense for you to fight with your brothers and sisters, which is what we are doing on Earth right now. You feel that you are part of the same family and that you can learn something from that kid. So why not be modest? My message is, let's be modest. That's point number one. Point number two, if we don't search, we will never find anything. And it's a self-fulfilling prophecy to say someone smarter than us is an extraordinary claim. I don't want to talk about it until there is evidence. My point is, extraordinary evidence requires extraordinary funding. So if I had $1 trillion, I would get you that evidence. The thing is, we have not engaged in the search. What we did in the past 70 years was a method that Frank Drake, who passed away just last year, initiated, which is listening for radio signals. We started radio communication, and at that point we said, okay, let's listen, check if there are radio signals coming. And that is just like waiting for a phone call at home. You sit at home and you're waiting for a phone call, like a radio signal. This requires someone to be out there that tries to reach you. And maybe they're not. Maybe they died by now. They lived a few billion years ago, and by now they don't exist. A better approach is check your mailbox if you have packages, because you might find packages for a sender that died by now. And that is something nobody did. That's what I'm trying to do now. And that's why I started the Galileo Project, because...
So you're studying these 4 objects that you mentioned in the beginning.
That's what started me on this path.
And that's the mailbox that you are talking about.
Yes, the solar near the Earth is sort of the mailbox. And so I was an astronomer working on black holes, working on the first stars in the universe, galaxies. And then came this object, Oumuamua, in 2017, discovered by a telescope in Hawaii. And Oumuamua means a scout, the first one. And it looked weird. It was flat in its shape. It was 10 times longer than it is wide, projected on the sky based on the amount of sunlight that was reflected from it as it was tumbling every 8 hours. And it was pushed away from the sun without evaporating, without any cometary tail that would give it the rocket effect. And I said, well, maybe it's pushed by reflecting sunlight.
What does that mean?
It means it's just like a sail. You know, a sail on a boat is pushed by the wind, by air.
Okay.
But light could also push a sail. It's just a weak force usually, and you need the sail to be very thin for the effect to be significant. But such a concept is being imagined for our future spacecrafts, pushing them by light sails. And I was involved actually in a project that wants to bring a spacecraft to the nearest star in 20 years. And the only way to do that is to push a sail with light so that it reaches a fraction of the speed of light.
It's so amazing that you are discovering that the light can push things.
Yeah, it can push things. Because think about it, it reflects from a mirror and it gives it, just like a tennis ball reflecting off a racket, gives the racket a push, you know. So I thought that is what's pushing it, Oumuamua. And then 3 years later, in September 2020, there was another object that showed no evaporation, no cometary tail, and it was pushed by reflecting sunlight. And then a few weeks later, it was the people at the same telescope in Hawaii. They realized, oh, this one, we can trace it back in time. It's actually a rocket booster that was launched by NASA in 1966. And we know that it had thin walls made of stainless steel. So reflecting sunlight was pushing it because it's very thin. So we know that this object, which is called 2020 SO, we know that it's artificial because NASA produced it. And the question is, who produced Oumuamua? Okay, so that was the question that I addressed in my book, Extraterrestrial. And the public was extremely excited about it. You know, it became bestseller. I had 2,000 interviews.
2,000, that's a lot of interviews.
Yeah. And there were some days where it was back-to-back, 8 of them. And a lot of people, it was during the pandemic, a lot of people came here. And now when I go places like, I was on an island for a retreat last week. And
so people recognize you in the streets now?
Well, yeah, that's one thing. But then there was a person at that retreat and he said, could I have a selfie with you, a video selfie? And I will send it to my boss. And he sent it to his boss. And then he said, the boss never replies to me. But this time he immediately came back and said, I can't believe that you are with Avi Loeb in the same place. So apparently there is a whole audience that I don't know about, that knows about me and follows what I do. I write a post on Medium every few days, but I don't know who reads it. And so the message got public, and the public is very excited, okay?
That was your goal initially, or it became random?
It became. I was intrigued by this object, so I just expressed my opinion. I felt that I'm just like the kid in Hans Christian Andersen's tale that said, the emperor has no clothes. And in this case, Oumuamua has no cometary tail. You know, the cometary.
That's
so
funny.
I said, and then people paid attention. The government also started talking about establishing an office to look at unidentified objects. Most recently, there were several balloons that were shut down, but those were clearly human-made. The question is whether there are other things that are not human-made in our sky. And my point is, if the government cares about this and the general public is very excited, Because
it seems like it. You get a lot of views in all the stuff that you are getting. So it means that there is an audience that cares about
and
this.
in science, very often funding committees that are populated by mainstream scientists, the mainstream scientists say, we don't want to take risks. Why? Because we will waste money of taxpayers. So they don't fund the kind of research I'm talking about. And then I say, how can you say that we are wasting taxpayers' money if you don't ask the taxpayers what they care about? Because if you were to ask them, they would tell you it's much more exciting for them to spend money on research to find whether we are alone than understanding the nature of dark matter, which is most of the matter in the universe. We don't know what it is. It has zero impact on our daily life right now. It's a scientific question that billions of dollars are funded towards. Most recently, the Large Hadron Collider was trying to produce the dark matter in the laboratory by smashing protons against each other, and nothing was found. So my point is, if we are spending billions of dollars on a question that is less attractive to the public, why not spend similar amounts of money, or even 1% of that? If you just spend 100 million or tens of millions on the search for interstellar objects and trying to figure out if there are anomalous objects in the sky, we can get very interesting results.
So your popularity helps you now to raise money personally if you want to do all these ventures that you want for research?
Well, so what happened as a result of my book, a number of wealthy people came here to my home during the pandemic and gave me money. One of them, for example, didn't even tell me that his name, or didn't tell me that he's giving the money. It suddenly appeared in my research account at Harvard University. And I didn't do fundraising. These people came to me. And
so he just randomly sent you money in your bank account?
Well, it was interesting because the administrator of my department says, you have $250,000 in your research account. And I say, what do you mean I have that? Where is it from? And she said, I don't know, but the development office at Harvard just told me that. And so I said, well, okay, I want to thank that person. Would you please let me know the name of that person? And it took a few days. She came back and said, this is the name. And they ask you, please, you can wait a few months before contacting this person. I said, no, I want to say thank you to that person. So I wrote an email to that person. Within a day, I had a Zoom meeting with that person, and I got another $1 million. So my point is, people are excited about this. But the strange thing is, within academia, there is a lot of pushback at the same time. And
you probably felt it personally, that pushback.
Yeah, I felt it personally because it's not only me. It's also people that work with me, the young people that need a job later on. They have to think, if there is so much pushback and people say ridicule or say bad things about this, perhaps it's a risk to their future career. But if you think about it, it's the most exciting thing you can pursue. The public cares about it. The government cares. There is preliminary evidence that we are seeing something unusual. The only way to make progress is by collecting more evidence. That's the method of science, the scientific method. If you ask yourself, okay, maybe the scientific community is conservative, and that's why, well, you look at theoretical physics, and what you find is speculative ideas that are in the mainstream, far more speculative, like extra dimensions, like string theory, they're celebrated for 50 years. And they're allowing people to do mathematical gymnastics and show that they're smart, but they have nothing to do with experimental evidence for anything. And so how is it possible that those are accepted as part of the mainstream, whereas if you see objects that seem unusual and you just say, let's collect more evidence, then people say, no. Extraordinary claims require extraordinary evidence. We shouldn't deal with that. And my point is, it's a circular argument because you will never get the evidence if you don't engage. And I'm just proposing following the scientific method. And by the way, a lot of people are excited about it, so why not follow that? And to me, it's a paradox. And the way I can understand it is there is always resistance to new ideas, okay? Obviously, because experts are getting their honors and their awards and everything based on past knowledge. So they want to believe that anything we see in the sky is a rock. It's a rock of a type that we've never seen before. Just like,
because they will stop being a legend. If we
exactly.
If we discover something beyond what they discovered.
Exactly. If you find that there is something much more important.
And maybe Einstein did that a bit in his late years.
Right. Well, yeah, Einstein made the 3 mistakes at the last phase of his career, but he was willing to make mistakes. He was working on the frontiers, and just, that's part of doing work at the frontier. You don't know what's right and what's wrong, and sometimes you go in the wrong direction. So that's a signature of being at the frontier, that you can be wrong. But what people now do is, for example, work in a sandbox like string theory, where you don't have experiments to test your ideas. So that's perfect, because you will never be proven wrong. Yes. All you need to do is mathematical virtuosity that shows that you are smart. And if your goal is to demonstrate that you're smart, that's the best of them all, because you will never be proven wrong. And you can get awards,
and
recognition.
It's a bit easier with science, because people that give them money, all this stuff, they don't really understand science. So they're, string theory, it must be important. So,
right.
So, and
right.
that is
but
a cycle
that's a wrong message to send, because actually in science, the key is to learn something about reality. Okay? Because just think about it in terms of the metaverse. You put goggles on your head and you imagine a reality where you look like Brad Pitt and you live next to celebrities and you're happy. And you take recreational drugs. It's the same effect, that you feel good. But that's not actually science. What science is trying to deal with the reality that we all share, not imagine something that flatters your ego. And that means looking at the pimples of reality, because, what is true is not necessarily beautiful. When I met my wife, I told her, I don't want you to put any makeup, because I want to see you the way you are. That's true love. You want to see the other side the way it is. Okay, you don't want to put goggles.
And what she said? Okay, I'm stopping.
She thought it's romantic, actually, because you are not trying to fake it. And I don't mind if there are things that do not complement our ego. That's not the issue. My ambition is to know the reality the way it is. And I love nature. I grew up on a farm. I jog every morning, this morning also in the snow, and I enjoy the company of wild turkeys. And I saw 5 of them this morning, bunnies, ducks, birds. So I enjoy nature. And I don't care how many likes I have on Twitter or social media. I think it's a distraction, because it's not about us. It's about nature.
How do you treat all these likes on Twitter and all these views and all these?
I ignore them. I have no account on social media. 0. I don't have any account. I don't waste my time on that. I just focus on substance, because, a few years ago, my parents passed away. And I said to myself, we have such a short time to live. Why try to be popular? Why try to convince other people to be liked? That's not really what matters to me. I want to understand the reality that we live in. And in the context of humanity, the biggest question you can ask in science is there another intelligent civilization? Because it will change everything. If we find it, we will have a view of what our future is like. It will change our aspirations in space. It may change the way world politics works. It will change religious beliefs. There is nothing more important than that. So here I am, worried about this question for the benefit of humanity, not to do with me. And here I am, resisted by my colleagues in academia, which I find strange, because academia is supposed to embark on new territories. But let me give you another example. When I started doing physics, which was maybe 40 years ago, actually, there was a very popular idea which is called supersymmetry, a new symmetry of nature. And the Large Hadron Collider that was constructed a decade ago at the cost of $10 billion was supposed to search for that symmetry, for particles related, new particles, the lightest of which should have been the dark matter, which is the most abundant form of matter in the universe. We don't know what it is. So anyway, it searched and didn't find it. Okay. So what did physicists say? They said, oh, well, maybe it's around the corner, maybe it's not in the range that we thought, but we need to build a bigger accelerator. Now, what did it remind me? It reminded me of an Orthodox community, Jewish, in Brooklyn, which is called the Lubavitchers. And they had a rabbi. And the rabbi was considered to be a very good candidate in their mind for the Messiah. So they believed in that so much that they built a copy of his apartment in Crown Heights in Brooklyn and put it in Israel because the Messiah is supposed to arrive to Israel. So they wanted him to find the toilets easily. So they made a replica of his apartment in Brooklyn and put it in Israel. And then he died. And they believed he will come back as the Messiah. And then he didn't come back. Just like
they believed that he will wake up again?
That was the belief about the Messiah, the coming of the Messiah, which is also, something that is common to Christianity.
So they were treating him like a Messiah.
Before he died, and then he didn't come back. And by the way, both Christians and Jews believe in the coming of the Messiah in the future. The only difference is that the Christians believe that he arrived already, and then he will come back again. So there was once a suggestion by Martin Buber, a Jewish philosopher. He said, why argue? Let's just wait until he arrives, because both religions believe that the Messiah will arrive. And then we can ask him if he visited already. But
that's
anyway, he didn't come back, the rabbi of the Lubavitchers. So then it's just not finding the dark matter. So what did they say? They said, oh, we just need to wait more. Okay.
Because they didn't want to look stupid that we just wasted $10
my point is what you find in religion. You might say, oh, maybe scientists are elevated into a different cognitive state where they say, oh, if the experiment doesn't find what I look for, then I say it's wrong and I move on. No. In both cases, it's human nature to argue, well, maybe it's around the corner, and scientists operate just like those believers. And it's worse than that in the sense that many scientists work on things that cannot be tested experimentally just because they think it might be real.
So
and they
science is the biggest religion of the 21st century.
No. So I said that's not the right way of doing science. The right way is to regard yourself as a student of nature and to learn from nature, because we would never come across quantum mechanics. The fact that you're recording this conversation is based on your cameras, then you will show it on the internet. That's all based on our understanding of quantum mechanics about a century ago. That's when it was discovered. Nobody expected it. It was completely a surprise, and it's still philosophically not very well understood how reality works in quantum mechanics. But my point is, it was forced on us by experiments. And there is no way we could imagine it ahead of time. So therefore, we should not be arrogant. Again, we should not think that we can come up with the correct description of reality just based on our thinking, which is a mistake.
We should shut up and test.
Yeah. Well, not shut up. You can say whatever you want. But the point is, collecting evidence is key to making progress. And we should put money.
So this is how you are going to spend your trillions.
Yes. Two things. One, checking if other civilizations did it already, what I want us to do.
How?
By looking for gadgets or devices.
Built-in telescopes, built-in...
Yes, and I already started that. Not far from here, there is the first observatory. So from the donations that I received, I established the Galileo Project. It's called after Galileo for an obvious reason, that we want to find the truth by looking through telescopes, okay? And based on prejudice. So you
named it. You named it.
Together with my colleague, one of the donors, Frank Laukian, who is has a PhD and is also the CEO of the Bruker Corporation. At any event, by now, the Galileo Project that I'm leading built the first observatory.
What do you mean the first? There is no other observatory?
There is no other observatory like it that monitors the sky for unusual objects. What we are doing is from one location, we look at the entire sky all the time.
Can you?
Yeah.
Because it doesn't make sense in my brain. How can you watch the entire sky?
Okay.
Is the earth behind you?
Yeah, you can. If you have enough eyes, you see, we have only 2 eyes. And I sometimes wonder why we don't have an eye in the back. It could have saved us from some risks. But you know why we have 2 eyes and not just one? Because with one eye, you cannot tell the distance. So if you see a lion coming towards you, you will not know how far it is. But with 2 eyes, you see it from different directions, and it gives you a sense of distance, 3 dimensions. But 3 eyes, for some reason, we don't have, unfortunately.
Maybe in the future.
Fish
evolution.
have eyes on the side that look much farther to the sides. So one of our cameras has a fish eye lens that looks at the entire sky with one lens. Okay. It's like a round. But then we have also 8 other cameras in the infrared that basically...
So telescopes are cameras.
Cameras, exactly.
So you monitor 24/7 and you record 24/7.
Exactly. We take a movie of the sky. And then we have artificial intelligence algorithms.
So you are a director.
No, I'm not dictating reality. I'm just an observer.
Okay, good.
Actually, personally, I'm a theorist. And the fact that I'm leading an observational project is because nobody else is doing that.
Yes.
So we are getting the video of the sky, but also the audio. We are recording.
Wait, I want to say something about what you said. I found this to be true a lot of times. The people, because it's not that they want to change the world, it's not that they want to go and do this thing, but nobody else is doing it. So shit, I have to do it myself.
Well, by the way, when I was young, I was mostly interested in doing research. Because I said, why should I waste time on administration, being the chair of the department, that's just a waste of time. I want to do my research. And then I realized that people that do the administration don't do the right thing. So then I realized, okay, to improve my environment, I must take responsibility. And so I became the chair of the astronomy department at Harvard for 9 years. I was the longest serving chair, 3 terms. Now, my wife, when I started this, said, you will not last very long because you are straightforward. You cannot say one thing and then do something else. And it ended up serving me very well because people never suspected that I'm tricking them. So they always worked with me. And I was a chair of the department for 9 years. That was service, just like being a service person in a restaurant. You help people do the right thing. You bring food to the table. You make people collaborate correctly. You bring new people to the place. And so I try to advocate for
So you got
diversity.
a lot of leadership skills from that position.
I learned from that. I was told that it will take all my time, but then it took only a quarter of my time. So it's a question of efficiency. If you are not taking the wrong exit in the highway, you save yourself a lot of time. If you take the wrong exit in the highway, you can go into bad neighborhoods and spend all your time there.
But how you do that? That's the art.
That's the art. You need to. Of course, the trip ends if you make the wrong turn. So gladly it didn't happen to me. There were 2 guiding principles for me. One, because I came from a very unusual background, I was promoting people from different backgrounds, different genders, So I tried to promote diversity as much as possible. That was important for me, just because of my experience. And the second thing is that I try to use the resources in a way that helps the people under me. So I was willing to get into confrontation with the deans just to help the people that are in the department, because they were the highest priority. And I said, if the upper administration fires me, it's just a benefit for me because I go back to research. It's not something I chose to do because I enjoy it. It's something I did as a service to the people working with me. So these were the two principles, and it ended up well. And now I'm back to research, but I changed my priorities to do research on something that matters. And this is an amazing subject because it matters to so many people. And it's about time for academia to embrace it. And for some strange reason, I get friction, resistance. I think it will change. And one way to change it is to find evidence that will be beyond any reasonable doubt. And that's what I'm working on.
So I want to put a question there. Like, for me, generally, I found a lot when it's a for-profit organization, they tend to be a lot more successful in something than the government, than all this stuff. But you seem that you are asking, for example, for the government to allocate budget on that. Like, is there any better way?
Oh, no. I get funded mostly by the private sector. So I do think innovation comes from the private sector, and I would much rather have this funded by the private sector. I'm just saying that the formal procedure of getting science projects funded usually is coming from government. There are organizations like the National Science Foundation or NASA that fund most of the research in astronomy, and that's the traditional way. I'm getting funded, all of my funds are private sector, and I think that's in principle much better because there are many more people with a vision outside academia that
can you make what you make as a for-profit company? Because when it's a for-profit company, then you can get the gains and invest them back and grow these things.
So that's part of the reason why we established also, in addition to the Galileo Project, which is not for profit, we established the Copernicus Space Corporation, which may be for profit if it succeeds.
But how do you make money from space? That's
You provide services that are helpful. So there is a whole program of going back to the moon, and if we provide services, that could provide.
So you provide services to the government, to other
exactly,
because you create a more valuable service than they already have.
Exactly,
and so you have them as, oh, that's interesting.
But you are right. That's one way to build a very strong, financially strong program. Ultimately, there is no commercial benefit to leaving the solar system. You cannot sell anything by leaving the solar system
yet.
I mean, except for legacy. If you say, if you give me, let's say, $1 billion.
So you are limited in making. That's very interesting. You are limited in making money if you start thinking about out of the solar system, because nobody is interested in this planet to do business with people.
Yeah.
About the.
Well, there is one caveat. People might want to have a legacy. Okay, so they might want to send something that represents them far away.
Okay.
For example, personally, I would love to go to space, okay? I didn't receive any opportunity yet, but if there will be an opportunity, I will go.
We'll have it here. Please invite Avi to space.
And let me tell you my real dream. It's not like the dream of Elon Musk to die on Mars. It's that my body will float in space. I might die by then, but then it will be kicked out of the solar system by a planet. And then I will go through interstellar space, let's say for 1 billion years. I will be dead, doesn't matter, in a space suit. But then I will collide with another planet like the Earth. And I will burn up in the atmosphere like a meteor, big fireball. And then there will be a scientist there that is curious about this meteor that is interstellar and wants to find out what it is, collects the fragments from the fireball, and puts them in a museum. That would be the biggest honor that I can imagine for myself. Being remembered by another civilization on another planet. And by the way, the reason I bring this up is because one part of the Galileo Project has to do with a meteor that came from interstellar space, the first interstellar meteor that we discovered with my student, Amir Siraj. And we're going on an expedition in 2 months. It's funded. We found the boat. Actually, today I just heard from the coordinator of the mission that visited the boat. It looks good. We're going in, hopefully in 2 months. And we will go close to Papua New Guinea, to the Pacific Ocean, and try to collect the fragments left over from the explosion of that meteor in the lower atmosphere. And if we find anything, now the reason we are doing it is because this object stayed together, maintained its integrity all the way down to the lower atmosphere. And from that, we concluded that it was tougher than iron. It was tougher than all 272 space rocks in the catalog of meteors.
So it's unlike anything we've ever seen.
Unlike everything. So, and that's the first interstellar meteor. So the question arises, how come this first interstellar meteor
It's okay. One light close. Don't worry about it. Continue.
The question arises, how is it possible that the first meteor from interstellar space is tougher than all the space rocks that we had seen from the solar system with roughly the same size and of order 0.5 meter? And we want to figure out if it's a rock from some system that is different than the solar system, or it's not natural. It's a
synthetic.
Yeah, it's artificially made, manufactured by a technological civilization.
Like a rocket of Elon Musk, for example.
Or an astronaut that burned up, like I was talking about before. So, so we are going there, and let's see what we find.
Tell me about black holes.
Well, black holes are the most extreme structures of space and time, in the sense that it's the ultimate prison, okay? There is a region of space that if you get inside of it, you can never check out. So it's a one-way trip, and if you have a friend that is texting you and sending you DMs, once the friend gets into the black hole, you will stop receiving messages. Now, it's a solution of the equations.
Is he going to die immediately and break
Not immediately.
apart?
So, in fact, I gave a talk about black holes at the school of my daughter when she was young, 10 years old. And one of the students asked me, what will happen to my body when I go inside a black hole? And I started explaining that.
And how do you know? And anyway, by the way, how do you know what will happen?
Because we have the theory that describes gravity. Einstein formulated it back in November 1915. He wrote an equation that is called general relativity, Einstein's equations. And we can use that to predict what happens to any object that comes close to a black hole. And a black hole was actually a solution obtained by a physicist named Karl Schwarzschild, who was the director of the Potsdam Observatory. At age 42, went to the military for the First World War. And he was a patriot. So he went to the front against the Russians and died there. But before he died, he sent a few postcards that give solutions to problems in physics, one of which was Einstein's equations have a solution when you put a mass at a point, and that is called the Schwarzschild solution for a black hole. So Einstein received that postcard and was very impressed. That was the first solution of his equations that made sense, that was complete. And now it's called the Schwarzschild solution. So in that solution, there is a region of space from where nothing can escape. That is called the horizon of the black hole. And then at the center of the black hole, there is a so-called singularity. And that simply means that Einstein's equations break down, because what was Einstein's idea? It was gravity is not a force, Einstein said.
So wait, you are talking about that you are talking about that we know a lot of things about this thing. So we know exactly what will happen if I throw my phone in, and like that's it. There's no unknown things about it.
There is no unknown as far as your phone is concerned. I will explain in a minute what we don't know. So Einstein's insight was that gravity is not a force. According to Newton looked at an apple falling and said, oh, something is attracting the apple to the earth. There is a force of gravity. Einstein said, no, I don't think so, because actually Galileo dropped different objects and they arrive at the same time to the ground. In fact, an astronaut that went to the moon dropped a feather and a hammer. At the same time, they arrived to the ground. And because there is no air, so the feather doesn't feel any resistance, so they fell exactly at the same time.
That's funny.
So that says that to Einstein, he was really insightful, because he said, well, that's actually a very interesting point about gravity, that all the objects behave the same way. So that means that gravity is not a force, that maybe it's a property of space and time, because all the objects respond to space and time. So he thought of gravity as curvature of space and time. And think about a trampoline. If you put a bowling ball in the middle, it curves the rubber of the trampoline. So now you put a marble, you give it a kick of appropriate strength, and then the marble would move in a circle.
And this is what we are in space.
So the Earth is moving around the sun. It's not a force of gravity. It's the curvature of space and time that the sun is inducing that is causing the Earth to move in a circle. If you remove the sun, it's just like removing the bowling ball from the center of the trampoline, and the marble on a straight surface will move on a straight line, and the Earth would fly out the same way. So gravity is just the curvature of space and time. And what happens in a black hole is...
It's the first time that I understood what gravity is.
Well, that was Einstein, that was an amazing insight. And he was correct. We know that to a very good precision. We also... If you take two bowling balls on a trampoline and you let them move around, you will create waves on the rubber. And in the same way, two black holes create waves in space and time. These are called gravitational waves. And we detected them. And the Nobel Prize was awarded a few years ago to that discovery.
What we detected?
We detected the small ripples in space and time that came from the edge of the universe where two black holes collided. That's amazing.
Somewhere else.
Very far away. Billions of light years away.
And we detected that
the ripples in space of time.
The two black holes.
Yeah, there was no light emitted because black holes are black. It's just space and time curved.
And if there is no light, how do we detect it?
Because space and time oscillate. Like the ripples in the rubber. So imagine the two bowling balls moving. There are ripples, waves in the rubber. And you can detect the waves in the rubber. So here it's the waves in space.
What amazing science is. It's beautiful.
Yeah, it's amazing.
And
it was discovered with lasers. So you saw that the distance, if you put a mirror, the separation of the mirror from the laser changed a little bit because these waves were passing. And you can detect that and say that a gravitational wave passed through. That was the idea. So so that was Einstein's equations, and then Schwarzschild derived a solution for a black hole, and in the middle of the black hole, the curvature of space and time goes to infinity, diverges. And Einstein's equations break down. So his theory is not applicable, and we understand why, because it doesn't have quantum mechanics incorporated in it. And we don't have a theory of quantum gravity as of yet that we can trust, that makes predictions. But your body, if you were to fall there, your body will be ripped apart by
with a lot of blood going.
So I started saying that in the class of my daughter, and the teacher said, please stop, because the kids will have nightmares. But the point is that the force, or actually your head...
I'm sure the people watching there, please continue.
The reason you will be ripped apart is because your head will be in a different place than your legs. And so the curvature of space and time being so strong will rip your body apart. Okay.
And what is the use of black holes in the universe?
Oh, they are just made from matter. For example, they are made by, imagine a star much more massive than the sun. A star is just a nuclear reactor. It basically is fueled by nuclear reactions, and it's held together by gravity. So a star is just a ball of gas that came condensed and then became very hot, so that nuclear reaction started to take place in the middle, and then that keeps it. And then at some point, the nuclear fuel is consumed. It's finished. So then the star collapses.
And this is what black hole is.
No, so a very massive star that is more than 10 times the mass of the sun can, in principle, collapse to a black hole. And then what you end up with is a black hole in the middle from the core of the star that collapses. So that's one way to make black holes. There is another way, which is at the centers of galaxies, like the Milky Way. We have a 4 million times the mass of the sun black hole there. And the way it was made is because gas went to the center, just like water circling.
And are they the same black holes? Or
just much more massive. So the stars are typically 10 to 100 times the mass of the sun, those that make black holes. But in the center of a galaxy, you get up to 10 billion times the mass of the sun, because there is a lot of matter in a galaxy that can go to the center.
So they are the same but bigger.
Much bigger. And then
do they have the same effect inside? Are they the same strong, or the bigger one is stronger?
Very different. So for example, when you make a black hole very big, you can bring matter with very low density to make it. For example, if you fill the orbit of Jupiter around the sun with water, you get 100 million solar mass black hole. You get a black hole that weighs 100 million times the mass of the sun. Just filling it with water, the entire orbit of Jupiter around the sun. And if you go make a black hole much bigger, then you can do it with gas, with air, for example, if you fill up such a big volume. So the bigger the black hole, the less is the density of matter inside that is needed to make it. And we can, in nature, so far we saw only black holes that are made by stars collapsing or by matter falling into the center of a galaxy. But in principle, the universe started very dense and it's expanding. So in principle, it's possible to make black holes that are small early on in the universe. And maybe the dark matter is made of black holes. We don't know.
There is a lot to unfold there, but I'm very curious to ask you another question about what if all the stuff that we are seeing here, the stuff that we see is fake, and actually you are searching in the wrong place to find alien civilization?
Well, the point is, in 1933, an astronomer named Fritz Zwicky looked at galaxies in a group and noticed that they are moving too fast compared to the amount of matter that binds them that we see, like stars and gas. So he said, well, maybe there is some matter that we don't see, invisible. He called it dark matter. That was 1933, 90 years ago. Since then, we obtained much better evidence that dark matter exists. This is a form of matter that is different than what we are made of. We don't know what it is. We just call it dark matter because it's dark. We cannot see it. And the question is, what is it? Now, if you imagine the dark matter making its own objects, making aliens, or if aliens, for example, use the dark matter for propulsion, like fuel, because there is more of it than ordinary matter, you will not see it. You will see nothing coming out of the exhaust of an engine if the fuel is dark matter. So to answer your question, until we figure out what dark matter is, everything is possible.
But you are still looking in the physical world. But I interviewed Donald Hoffman for this podcast. I don't know if you know him, and he suggests that all the stuff that we are seeing is like a virtual reality. And when we take the headset off, it's like this might not be the real thing that we. So while you are searching on the physical world,
right?
All this stuff.
I believe in the physical world. I don't think that we live in a simulation or because. it's a luxury to believe that we live in a simulation is a luxury that people that maybe have a lot of money can have, because if you need to check your bank account and you are held responsible for consequences of being bankrupt, or obviously you have to believe that the reality that you're in is real, because you live by the consequences of the actions but if you are in a comfortable situation where you don't get much friction with reality.
He's suggesting is let's say we are in Minecraft it's a game, or GTA, so he's suggesting that the stuff that we see real, and if a car hit us, it actually hit us, but that's inside the game. So we're inside the game,
right?
And there is something outside that we don't know.
It will be difficult to show that it's wrong. I mean, one way to show that it's right is to find, for example, that reality is pixelized, that are pixels, or that you will find a bug in the program, something that doesn't quite work. And to me, reality is real.
But aren't you conservative to just believe that reality is real? Like you said, all this scientific stuff, you are not open to different possibilities and all this stuff.
Because I don't think they will lead us anywhere. I think most important for us is to adapt to the reality that we see around us, okay? And therefore not consider hypothetical things, because they will not lead us anywhere. So we need to respond to what we see, okay? That's what. Now, whether what we see is real or not, that's a metaphysical question. That's something I cannot address. But all I'm saying is, let's experiment with reality. Let's, engage with it and see what we get as input and adapt to it, rather than imagine what it might be, so that we feel good about ourselves.
Or maybe maybe we can do experiments to find what it is.
Yeah.
The other thing.
Exactly. If you can imagine experiments, then it's worthwhile pursuing, because it can teach you whether you're right or wrong. But if you cannot imagine an experiment that will teach you if you're right or wrong, I don't care much about it. Not so much because it must be wrong, but because I cannot make progress, okay? I want to make progress. In other words, after I spend some time on this problem, I want to know more than I knew before.
So your style, I understood, is more let's not philosophize and just sit here and fart around. Let's actually sit down, see what experiments we can do to test and have progress to one direction. Might be the wrong direction, but let's have progress to one direction of more understanding.
Yeah, and by the way, I started as a young kid mostly interested in philosophy. I was attracted to existentialism, which is not pretending something, but actually living the reality that, without pretending something else. But I then became a scientist, and the way I think about it now is that, we have an obligation to adapt to reality, and we have to figure it out. And that is our biggest obligation, because it allows us to grow in the way we think about the world. If we have the wrong ideas, we can learn something new, but by experimenting, and reality will teach us what's correct. And altogether, I think the humanities, philosophy, for example, instead of focusing on what the ancient Greeks said, and I know that you're Greek and you're proud of the philosopher. I read Plato and Aristotle and Socrates. I admire them. But my point is, they didn't have Instagram. They didn't have, social media generally, but also AI. They didn't have internet. They lived in a different reality. So instead of reading and learning what they thought, we should have humanities of the future, because there are lots of ethical questions in the context of AI, like to do with privacy. When Instagram started, it had a huge impact a decade ago on young girls that was never thought about in advance. Social media had created a lot of polarization in society. There are lots of issues that people that are doing philosophy or psychology can contribute resolving. So we need to put regulations on the way that social media is handled, the way that the internet is handled, because
but you don't think it's like there is a big use to study the philosophers and like study the Greek people that you mentioned, or you say that let's focus 5% of our time there.
Let's focus a small amount of our time on the past. There were very wise people in the past, but the reality that they lived through is very different than the reality that we live through. And there are lots of risks that come with the new technologies. A lot of risks, just like nuclear weapons. Nuclear energy you can use for good purposes. You can build nuclear reactors, but you can also use it for military purposes. And you have to regulate. There were all kinds of treaties about nuclear weapons so that we will not have so much risk to our existence. And in the same way, the internet brings risks, and you have to cope with them. And people in the humanities should deal with the humanities of the future just to help society to navigate it in a direction that is healthy. And we didn't do that so far. And I'm saying this is urgent, and humanities of the future are really important.
So what are the biggest problems that you see we face now?
I think there will be 3 revolutions that humanity will encounter potentially in the coming century. The first one we already witnessed with ChatGPT and AI becoming more and more sophisticated.
I love seeing people at your age to know about these things.
Really.
And it's difficult to find. Like, if I'm sure 99.9% of the people at your age, they don't have any idea about AI.
I'm going on an expedition to the Pacific Ocean in 2 months, and my undergraduate student said that he will feed all of my essays on Medium to a ChatGPT and try to reproduce a new essay when I'm away and see if the audience recognizes that.
That's funny.
So the question is whether the system will be as creative as I am. If I will not feel offended if people cannot tell the difference. So I think the best. It will happen in the future that we will have sentient AI systems. I think it's inevitable. And by sentient, I mean that millions or even billions of people will not be able to tell the difference over years, whether they're conversing with a machine or a person. That's the Turing test. But also the machines will do creative work, and they could create art. They could create science.
So you think that will be one of the problems?
Well, that's a challenge because you want to navigate in a direction that is constructive, that is not destructive. And if you look at governments so far, they use nuclear energy also for nuclear weapons. So they could use AI as weapon. And we need to make sure the difference from nuclear weapons is that AI systems are developed by artists and scientists, and we can take charge of what we develop and make sure the governments are not misusing it, because it's developed in the private sector rather than the government. Nuclear weapons were developed by the government to start with. So that's one important revolution. And when AI systems become sentient, unplugging a system from the wall would be just like pulling the trigger on a person. Like the legal system will have to change. And AI systems may communicate with each other and create their own community. So that is another challenge because they will have different agenda than people, perhaps. So that's one challenge, AI. The second is if we increase the longevity of people, if we understand how to repair the human body.
To live longer?
Longer than 150 years.
Or live forever.
In principle, if we know how to repair, we might find a way to maintain the human body forever. And that will change society.
I love that you use the word in principle.
Because I think of the human body like a machine. You see, I don't see anything beyond that. And I know that, we can repair cars. The one thing about the human body is when you get a wound, when you get hurt, I got hurt in my finger yesterday, the human body repairs itself. A car doesn't repair itself. So biology is really quite amazing that it does it. But in the future, we might be able to avoid aging by repairing it in a more fundamental way. the human body. And that will change society. So that's the second challenge, how to reorganize society if humans live very long.
And if we live forever, that will be, then we have a better chance for AI, for us not to be extinct completely.
Yeah, or we can go to very long interstellar travel.
Yes. But this is the only thing that you are thinking about.
Yeah. So the third revolution, which I think is the most significant, is if we discover an extraterrestrial technological civilization that is far more advanced than we are, because it will include the other revolutions. They may already have very advanced sentient AI systems and long-lived biological creatures. And so I think this is the most important revolution of the three. And that's what I'm working on, trying to advance it.
So can you tell me the logistics of let's say your body, they put you in a spacesuit, like when are you going to die, melt every ounce of your body, like 1 billion, how much time it takes, and like is it possible for a planet to push you, and like is it possible to be floating through space through billions of years?
Like, it is possible.
What they're going to find, they're just ashes of you.
Okay, so you will survive in space as long as the human body will not be completely evaporated over a billion years. Okay, something will survive. But especially if you are protected by a spacesuit, okay? I was just imagining a situation where I will float in space and come close to, for example, Jupiter, that will give a kick. And that is possible. A lot of rocks...
Or maybe light will push you. Or because...
If I'm attached to a cell, I can open up a parachute. In principle, you can design a parachute such that the sun will push me, yes. But... anyway, this was just a fantasy. I mean, obviously, I asked my wife, if we will have a spacecraft in our backyard and they will call me in, what would your response be? She said, well, if you really want to go, just make sure you leave the car keys with me. And that was 10 years ago when she said that. I asked her again a month ago. And this time she said, well, I changed my answer. I will ask you to turn off the lights and I'll join you because I'm so worried about what's happening around the world. So I would like to go with you. And that's progress. You see, in my marriage, we come together.
You convinced her. She bought in the vision. So now that you're talking about love, can I have your take about love and like if you... Because I'm a bit skeptical about the whole, because like in movies they make it like this is the most beautiful thing, like maybe should like what do you think about love?
Well, I think love is a good reason to stay on Earth, okay, and because you will not easily find it in space, and if you find any partner in space, they would look so weird that it will not be a good date. Let's put it this way. I would not recommend making dating apps for extraterrestrials because their bodies might look not very appealing.
And you might not be able to reproduce with them.
That's another issue. And, altogether, it will not look like an attractive option. I am willing to bet. But so in terms of love, we are talking about here on Earth, and I think it's very important. It's sort of the cure to all the frustrations that we encounter during our life. Okay, and so it keeps us together and it keeps us in a healthy situation. And but if you think about it from a biological point of view, it's the connection that allows nature to reproduce itself, to have babies, and by that maintain longevity. And so those people or animals that did not have a connection, within one generation, they disappeared. Okay, so it's clear that you need love, you need a connection in order to stay as a species. And That's why we find love as a common thing.
So I'm very surprised by our conversation, and now you became one man that I look up to live by the principles that you live your life by. Some humbleness, some mission-driven life. So I'm 22 years old.
Oh, wow.
So what advice do you have for young people like me and people starting their life now and taking their decisions about life?
Well, I think being young is amazing. I enjoy working with young people. I was asked recently, what is the recipe for a paradigm shift, changing the way people think about science? What is the best way to do that? And my answer was two things, two parts. One, work with young people because they don't have a baggage. They don't have a prejudice. They are not attached to their ego as much as the adults are. Because it takes time to get attached to yourself. By the way, I'm not attached to myself because I think about my body. Just like, if you go to a dealership and getting a new car, you shouldn't be proud of driving that car because you didn't design it, you didn't manufacture it, you just got the car and you're driving it. So nothing for you to be proud of. So I got my body from my parents. I didn't design my liver, my heart, my brain. So why should I be proud of myself more than anyone else? Anyway, so my answer was working with young people is a guarantee to, advancing without putting blinders, like adults put blinders. One of the things that always frustrated me as a kid was sitting around the table at dinner and asking a difficult question, and then the adults in the room would either dismiss the question because they didn't know the answer or invent a story that made no sense to me as a kid. It was clear that they don't know the answer. And I don't like that because I see the same phenomena among scientists that say, something is an extraordinary claim, and they don't look for evidence. And I thought that by becoming a scientist, I have the privilege of finding the answer for myself. And young people are willing to consider interesting, exciting possibilities that are not like what is already known. So that's why I enjoy working with them. And the second part of my answer was you need funding from the private sector, so that you don't rely on those committees occupied by mainstream physicists that preserve past knowledge, okay? So these are the two elements. And so my advice to young people is stay young in the sense of an attitude, an approach. It's not a matter of biological age. It's a matter of always willing to explore something new, the unknown, willing to innovate, not being trapped in your ego, not being trapped in the way people thought about things in the past. Just, it's a new world, so to speak, for you every day. And that's an attitude. I'm happy to be in that state of mind, and I enjoy working with young people for that reason. The second advice to young people is, and I said that to my class actually just a week ago, I said, don't listen to authority, okay? Just find the truth yourself, because authority has other reasons to say what it says. For example, I watched this film recently, a few weeks ago, All Quiet on the Western Front. It's about the First World War. And you can see these young people marching towards their death, to be slaughtered by either machine guns or swords, and you ask yourself, why would they do that? Just because a politician or their commander would say march, you see your friends dying, makes no sense. My grandfather fought, he was on the German side against the French in the First World War, and in that battle that is called the Battle of Verdun, 700,000 people died. 700,000 in one battle over 4 years. And the line between the French and the German over 4 years didn't move. So think about it. 1,000 people died for nothing. Nothing. There was no benefit to either side. And you ask yourself, what's the point? And it's all because the young people listened to authority. That's all. They were excited. They were willing to sacrifice their life. And what is more precious than life? We live for maybe 70, 100 years, and now you want to shorten it to 20 years? Like, that makes no sense to me. Why would you want to sacrifice everything you have just because someone said something to you? And the following morning, I came to my class and I said, don't listen to authority. That was my main takeaway from this film.
So fuck rules and fuck authority?
Yeah, well, when you say rules, you have to be careful. You don't want to be unethical, okay? You don't want to kill people. You don't want to steal because you don't want people to do that to you, okay? But in terms of what you work on, what you think about, yes, be independent, pursue your own path. And second thing is, don't sacrifice your life just because someone said something. Don't ruin your life for that reason. Be independent, just think critically. And, it's not easy to deviate from the beaten path. There is this poem by Robert Frost, who lived not far from here, and he said he took the road not taken, and that made all the difference for him in his life. And to me, as a scientist, taking the road that nobody else took makes a lot of sense because there might be low-hanging fruit. Nobody picked it up because nobody took that road. And my advice to young people is take some roads that nobody took. That's the fun. When I jog in the morning at sunrise, there is nobody else around. That's great. I enjoy it. If I were in Manhattan with, millions of people around me, I would feel, what's the point? Like, if I go to the train together with a lot of people that do the same thing the same time and come back home at the same time, and it's all looking the same, I would lose my meaning of life. I would lose my interest because I enjoy doing something new. There is no point in repeating things. We already know that. Let's find something new. And the point is, what we know is just an island in an ocean of ignorance. There is so much we don't know. So I just want to learn something new.
Thank you so much for your time. I love this. You inspired me to be excited and do stuff and be a better person. Thank you for your time. I love you.
My pleasure.